Video, we are going to begin discussing systems of equations. So yesterday you had a refresher on how we graph lines. We looked at lines in standard form, slope-intercept form, vertical lines, and horizontal lines. And so remember that when we started solving systems, the way we introduced these was looking at graphs and saying that a solution of a system, the point that satisfies both equations, is on a graph the point of intersection. So the way we're going to be treating these is just by graphing each line separately and looking for where they intersect. So we'll start with our first line, this one right here, y equals 5, and we will remember that y equals a number is a horizontal line, which means this line looks something like this, cutting through the y-axis at 5. Next line I'm going to look at right here, y equals 2/3 x plus 1. This is in slope-intercept form, which means I want to start with the y-intercept here, which is positive 1. And from this point, I want to move according to the slope, which tells us rise positive 2 and run positive 3. That's up 2 and over 3. And up 2 and over 3. And even if I didn't draw all of these in, we should be able to see exactly where these lines are going to intersect. And that is, of course, right here. Oops. That's, of course, right here at this point. And the coordinates of this point, the solution of our system then, is that intersection point at 6, 5. Moving on to our next line. So I'm going to start with this bottom equation only because this is a little bit of a simpler line. So looking at this first one, x equals negative 3. This is, remember, x equals a number is a vertical line. So we want to cut through the x-axis at that x-intercept negative 3. And our line should look something like this. Let me actually use a line tool. X equals negative 3, just like this. Our second line is in standard form, ax plus by equals c, which means I want to start this, I want to start graphing this by setting up a table of values. I have my x coordinate and my y coordinate. I'm going to choose to use x equals 0 to find our y-intercept, and I'm going to choose to use y equals 0 to find our x-intercept. So taking our equation 3x minus y equals negative 3 and setting x equal to 0 gives us the equation negative y equals negative 3. I'm going to divide both sides by negative 1 to get y equals positive 3 as our y-intercept. Next thing I'm going to do is set y equal to 0 to find the x-intercept. Setting y equal to 0 eliminates this and just leaves us with 3x equals negative 3. I'm going to divide both sides by 3 to solve for x and get x equals negative 1. And now I have everything I need to create these lines, or to create this second line, rather. So that's right here. We have an x-intercept at negative 1, right here, and we have a y-intercept at 3. And these 2 points are going to help us create our line. It's going to go like this. And now that we have our line here, we can actually see the point of intersection is right here. And we can see that that is the point -3, comma, -6, right? So we've just graphed both lines and looked for the point of intersection. Remembering that y equals is horizontal, x equals is vertical, y equals mx plus b is slope-intercept form, so we start with the y-intercept and use the slope. Ax plus by equals c is standard form, and we want to set up a table of values, right? Cover up this x value and solve for the y-intercept, and then cover up this y value and solve for x, the x-intercept. We're going to do one more together. So I'm looking at this first line right here and seeing that this is in slope-intercept form, y equals mx plus b, so I'm going to start with the y-intercept 4. And I'm going to use the slope, which tells me to rise 3 and run 4. That puts me right here. And now we have our first line. It looks something like this. My second line I'm looking at and seeing that this is in standard form, ax plus by equals c. And so the way I'm going to graph this line is by setting up a table of values again. So let's set that table up. And I'm going to use that table of values to help me find the x-intercept and the y-intercept. So we have a column for x, a column for y. I'm going to choose x equals 0 to find the y-intercept and choose y equals 0 to find the x-intercept. Remember, all that does for us is setting x equal to 0 eliminates this term and leaves us with the equation 4y equals 12. I'm sorry, 4y equals -12. And I'm going to solve this equation for y by dividing by 4 on both sides and get y equals -3. Next, I'm going to set y equal to 0 and find the x-intercept. So I've eliminated the y term, and I'm going to solve -3x equals -12 for x. I'm going to divide by -3 to do so and get x equals +4. And now I'm going to take these intercepts and put them on the graph. Y at -3, x at +4. I'm going to draw a line through these 2 points. And now I'm going to look for the point of intersection between the two lines that we've drawn, but of course we should notice that these lines are parallel, and so they're never going to intersect, which means we have no solution. So keep in mind that lines that never intersect have no solutions, and lines that are the same line, so if we have the same line twice, that's infinitely many solutions. So let's just make a quick note of that down at the bottom. So an example of a system with exactly one solution would look something like this. Anything where the two lines intersect exactly one time, right here. An example of a system with no solutions would look something like this, where the two lines are parallel and so they never intersect. And an example of a system with infinitely many solutions is something like this, where we have two lines and those two lines turn out to be exactly the same, and so they intersect infinitely many times. So remember, as you go and complete your classwork, that when you do so, you're going to want to make sure you go up to the top of Kami, it's just barely cut off my screen, and click the Turn In button when you're all done.